Okay, this is your answer video to section 6.1 of your Math Links textbook on determining the product using of mixed fractions, or sorry, of whole numbers and fractions. So the first part, question 6, is our first question, and it asks us to determine each product using manipulatives or diagrams. Now we said we're going to use modeling with rectangles for A and B, and then we're going to use modeling with number lines for C and D. So for A, remember that using what we call the commutative property of mathematics, this is the same thing as reversing it, because the order in which you multiply two numbers together does not affect the product. So interpreting it as four groups of a half is fine, or half of a group. We're going to use this particular interpretation here. So if I draw half and I shade it in, and then I say I need to have four of those, four groups of a half. There's two of them, there's three of them, and finally there's four of them. And then I ask myself the very important question: if I have four halves, how many halves do I have in total? The answer will be I have four halves, right? Four halves, which of course is an improper fraction. As a mixed, it's simply the number 2. So your answer for A based on the model is 2. And again, we could have taken this half here and shaded it over there, brought this one over here, and then this one would have been full, and this one would have been full, and I would have had 2. Question B, if I was to draw three groups of 7/10, or three groups of 7/10, I'm going to cut it in half, and then 4 lines between there, and then 4 lines between there. And now I have tenths. If I was to shade 7/10 of them using my highlighter, I'll do 1, 2, actually I'll make a bigger highlighter. Let's just go 7 would be right there, I think. Something like this. So now that I have 7/10 drawn, I want to have three groups of those. So I'm going to infinite clone it 3 times. And that would be 7/10 multiplied by 3, or 3 groups of 7/10. And the question I'm going to ask myself, how many tenths do I have in total? And the answer would therefore, I have 21 tenths, which is an improper fraction. It means I would have 2 full wholes and a 1/10 left over. And that makes sense, because if I was to take these 3 right here and put them here, that would be 1. If I was to take these 3 and put them here, that would be another 1, or 2, and I would have 1/10 left over. So 2 and 1/10 is the answer to the product of 3 times 7/10. Question C and D, we're asked to solve the same question, except this time with a number line. So for C, I'm going to make a number line, and I'm going to divide it into thirds. So I'm going to make this 0, this 1, this 2, and this 3, etc. And then I have to make them into thirds. So I'm going to put 2 lines between there to make thirds, 2 lines in there to make thirds, 2 lines make thirds, and I'll make this 4, and 2 lines in there to make thirds. So I want 5 groups of 2/3. So my first arrow will be from 0 to 2/3. That's 1 group. That's 2. That's 3. That's 4. And that's 5. That's 5 groups of 2/3. And if I ask myself, where did I end up at? I ended up at 3 and a third. So therefore, what is the product of that? It is 3 and a third. Or if you wanted to, you could say that is an improper fraction, 10/3 in total. And our last question, D, says 3 groups of 3/8. So I'm going to draw my number line for D. And this time I have to make it into eighths. So altogether, I'm only going to need, it's not going to be that many. So I'm just going to put it 0 here, 1 here, and 2 here. And in order to make eighths between 0 and 1, I cut it in half to make halves, half of each to make quarters, and half of those to make eighths. Same thing over here. Halves, quarters, eighths. So now I need to have 3 groups of 3/8. So my first group will be here. My second group will be here. And my third group will be here. Where do I end up at? I end up at 1 and 1/8. Or if you wanted to, you could have said 9/8. Question number 8, which is your second question, says the width of a Canadian flag is half of its length. What is the width of a Canadian flag that is 4 meters long? So if this is half of the length, or half of L, and I know that half, and I know the word of is multiplication, and I know the length is really 4, then this question and of course, because of the commutative property of mathematics, this question are both the same thing. So I can either do 4 groups of a half or a half times 4, right? Either way you think about it, if I think about this in terms of if I have a half and I multiply it by 4, how many halves would I have? I'd have 4 halves, which as a whole number is 2, right? So therefore, if the length is 4, the width of the Canadian flag must be 2. I don't particularly care for this question because they made the fractions too easy. I would have rathered them have, even a third. The Canadian flag is a third of the length, but I guess in real proportions, a Canadian flag is 1 part width to 2 parts length. Question 9 says a minibus that seats 12 people is 3/4 full. How many people are seated on the minibus? So 3/4 of the bus. For those of you who have a difficult time kind of getting your head around what math is involved, I want to know what 3/4 of the bus's population, right? So if I write it in words first and then realize that 3/4 of means multiplication and the bus is 12, really I have this question, or through the commutative property of mathematics, I have this question. I could then think if I have 3/4 and I have multiply that by 12. If I drew it once, obviously drawing it's going to suck, but we'll draw it once anyway. And I have 3/4. If I take that 3/4 and I infinite clone it, double it, triple it, quadruple it, and then do this a whole bunch more times, it does take a while. And there are 12 3/4. How many quarters would I have altogether? I'd have 36 quarters. Now, if you drew it, you're a sucker, because you could have just thought of it that way. And what is 36 quarters, or 36 divided by 4 as a whole number? It is 9. So therefore, there are 9 people, 9 peeps on the bus. 9 peeps, you got to pluralize it. 9 peeps on the bus. Question 10 says, what fraction of the surface area of a cube is on one face? I hate this question. I don't even want to do it. So surface area, if I was to take a cube, the surface area of a cube is all 6 sides. So it's assuming that you know that there are 6 sides in a cube, and in each side of that cube is a square. And if the entire cube, and I'll make this a red side, this is a green side, the blue side, etc., etc., etc. There's 6 sides. If I take that, then it's really, the red side is really 1/6 of the total surface area, the total surface area. So 1/6 of 6. Now I can probably do that in my head. If I have 1/6 and I drew it 6 times, how many sixths would I have? Oh, this is a lot of words. I would have 6 sixths, which of course is equal to 1. So if a cube has a surface area of all 6 sides of 6 centimeters squared, what does one surface of one face have? It's 1 square centimeter is one face. Question 11 says, Ron's car uses 12 liters of gasoline per 100 kilometers of highway driving. Asthma's car only uses 5/6 as much fuel. How much fuel does Asthma's car use per 100 kilometers of highway driving? So it's 5/6 of Ron's car. So words first. Then I want to do 5/6 times 12, or through the commutative property of mathematics, 12 times 5/6. If I had 5/6 and I drew it 12 times, how many sixths would I have altogether? I would have 66ths. Does everyone agree? If I drew 5/6 12 times, I would have 66, which as a whole number is 10. So if Ron's car uses 12 liters of gasoline per 100 kilometers, then Asthma's car would only use 10 liters of fuel per 100 kilometers. Question 12 says Nunavut covers 1/5 of the area of Canada. The area of Canada is about 10 million square kilometers. So Nunavut is 1/5 of Canada. or 1/5 of 10 million. So if I was to draw, obviously you're not going to draw this one, I don't think. But if you were to draw 1/5 and then infinite clone it 10 million times, how many fifths would you have? You would have 10 million fifths. 10 million fifths, which if you divide it, becomes 2 million. So what is 1/5 of 10 million? It is 2 million. What's the approximate area of Nunavut? It is approximately 2 million square kilometers. And question 13, your last question. I think it's your last. No, it's your second. Let's just go to this one. We'll leave that one. Question 17 is a ball dropped to the ground bounces back 2/3 of its previous height. If a ball dropped straight down from a height of 81 centimeters, how far does it travel altogether by the times it hits the ground for the 5th time? So when it drops the first time, it traveled 81 centimeters. Agreed? And then it bounces back 2/3 of 81. So everyone agree with that? 2/3 of 81. How many thirds would I have drawn? I would have 162 thirds, which as a whole number, if I take that and divide it, 162 divided by 3, means it traveled 2/3 of 81 or 162 thirds. It traveled 54 centimeters on its first bounce. 54 centimeters. And then it goes down again. And then it goes back up. But this time, instead of being 2/3 of 81, it's going to be what? 2/3 of 54. How many thirds would you have if you multiply 2/3 by 54? You would have 108 thirds, which has an answer of 108 divided by 3. It bounces 36 this time. How many times has it hit the ground so far? Twice. Let's go back down. It hits the ground again. Comes back up. Oh, we didn't go that far. It goes 2/3 of 36. How many thirds would it have bounced? It would be 72 thirds. 72 thirds, which if I take my calculator and go 72 divided by 3, 24 centimeters. Then it bounces again. 2/3 of 24 is 48 thirds, which is 16. Hold on, is it going to hit the ground now? Yeah? Hits the ground. Does it actually, hold on a second. Does it bounce one more time? So it bounced up 16 and then down 16, correct? Agreed? So let's figure out the amount. It bounced 81 plus how many 54s did it travel? No, it went 54 up this way and then 54 down this way. So 2 times 54, didn't it? Well, it says how long does the ball travel altogether? So it started here. It traveled 81 centimeters. It bounced up 54, which is 2/3 of that. And then it just fell down another 54. Then it bounced up how far? 2 times 36, correct? 36 up, 36 down. And 2 times 24, because it went 24 up on the bounce, 24 back down. And then it finally went 2 times 16. So this is going to be 81 plus 108 plus 72 plus 48 plus 32. Add those together. Let's see what I got here. These make 180, 260, 300, 330, 333. I think 333. No, plus this one here, plus that 8. 333 plus that 8 is 341 centimeters, I think, but I'm not 100% sure.